Okay, so we're going to start with some basic truth tables for just this video right here, and then we'll start with the conditional statements of if and then. Okay, so let's begin with some truth tables. All right, so let's start with just, all right, we're going to say P is a statement. So if P is true, then the negation of P is false. Okay, so this is what's known as the negation of P. And this is going to be kind of abstract at the beginning, and then we'll get into some actual theorems. Okay? And so if I was going to write this as a table, so if P is true, then the negation of P is false. And so P scoot it up just a little bit. And the negation of P. And we're not going to devote a whole bunch of time to this because this is very abstract. Okay, so that would mean that if P is true, then the negation of P would be false. Okay? And if P is false, well, then the negation of P is true. Hold on, we have somebody asking some questions online. Okay. Okay, so we have the negation, and then we have the conjunction. We're just going to go through a couple definitions. This, I think, is reviewed. Okay. So then we have the conjunction. Okay, so if we have P and Q, I always have a tendency to do that. Always have a tendency to draw a little dash right there because whenever I draw that symbol, I actually think of a different symbol. Okay? So if P and Q is true, then both P and Q are true. Okay. And I'm going to draw this as a truth table, but whenever I think of this problem, if I think about the truth of what this is, I think of this as an intersection. We use slightly different symbols when we talk about, like in class last time we were talking about sets, okay? And so one way to think about this in terms of a set or the truthfulness of the set is intersection, okay? Both P and Q have to be true. So if you were going to draw this as a Venn diagram, and so as a Venn diagram, Okay, so let's say this would represent the truthfulness of P, and this will represent the truthfulness of Q, and it would end up being the intersection of these two. Okay. So, one way to write this is as a Venn diagram. Another way to write it is a truth table. So P, Q, now P and Q. Okay, now we'll start off with, let's say both of them are true. So if P is true and Q is true, well, then, yes, P and Q is true. Now, if P is true and Q is false, they're both not true. So P and Q is false. Okay? And if P was false and Q was true, they would both be false. Okay? And then P and Q, false. P is false, Q is false. Well, they're both false. So the truth of P and Q is false. Okay, so we have the conjunction, we have the negation, and we have the conjunction, and then we have the disjunction. Okay, so the disjunction lined up right. Disjunction. Okay. Okay. So if P or Q is true, then either P or Q is true. Okay, so you can think of this one as a union. I mean, the connection between sets and logical statements is, some people get confused by this, but if you want to just kind of imagine that as a U instead of a upward pointing V, you can think of that as union, okay? So if you were going to draw this as a Venn diagram of whether P or Q is true, and if I had P and Q, what's it going to do? It's going to fill in everything. So that's what I kind of mean by union. Okay, so either, I mean, P or Q could be true. So if we write this as a truth table, so P, I keep on writing what I'm thinking. I actually have a tendency to do that a lot. Okay, so if P is true and Q is true, what would we end up with? We would end up with them being in that intersection of the truthful statement. And so, well, that's true. Okay? Now, if we talk about, let's say P is true, Q is false, well, either of them can be true, so that is true. Okay? If I say that P is false and Q is true, well, one of them is true, so the union of them would also be true. Okay? That would be like existing in this portion of the Venn diagram over here. And then we have the very last one. Well, if they're both false, it doesn't exist at all. So both of them are going, the union of them is false as well. Okay. Okay, so that's some basics of the definition. Now let's go through an actual problem involving this. So this one's going to get a little bit more complicated, but that's fine. Okay, so what the last part of this video, and I can see that some of y'all are asking questions online. Let me get through the video and I'll answer your questions. Okay, so we're going to try to ask this question. What is the truth table for the negation of P and Q and, or, because it's a union. Okay, so we're going to try to figure this thing out. So the negation of P and Q union with P union Q. Or I'll use intersection and union interchangeable with disjunction and conjunction. Okay. Wait a second to write that down. So we're going to go through this through steps. Okay? So let's start this off. When you start your truth table, okay? What are you going to do? Let's start with just P and Q. Okay? We just want to know, is P true or false, whatever. Okay. So this is what we're looking at. And so I'm going to start with P and Q. Okay, now our only options when dealing with just two of these guys is that we can have truth, truth. The order in which you do this is not unique. Okay? Then we could say truth, false, false, and true, and false and false. Okay. So these are the possibilities that just exist for the relationship between P and Q. If you add another variable to this, it gets bigger and longer. But let's just start off with, these are the possibilities. Okay. Now, given these possibilities, the first question that I would ask is, what would be the truth table for P and Q? Okay, so we'll just start with this portion of it. Okay? Okay, so if I talk about P and Q, we did this just on the other page. So P and Q, meaning that both of them have to be true. This would be true, false, false, false. Because both of them have to be true. Okay. So from there, if we look at the problem that we're actually considering, this is saying the negation of P and Q. Okay? So the next part of our table would say, okay, if I did the negation of P and Q, well, then that would turn to false. False would turn to truth. False would turn to truth. And false would turn to truth. So it just switch. Okay. All right, now we're going to have to consider the next one, which would be, okay, so we've got the negation of P and Q right here, right? So the next one we want to consider is the union of P and Q. And then we're going to ask ourselves the question, what would be the union of both of these sets? So we're going to look at this one first, and then we're going to go to the union of both of the sets. Okay? So P or Q. And I am probably going to run out of room on this page. We'll put the last answer down right below this. Okay. So let's look at our truth table. Starting with the options that we have over here on the left. So we're not considering this one and this one. We're just saying we're going along this table right here as P or true true. P or Q true. All right. That would be true, 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 and false. Okay. Now, we're at the very last step of this problem right here, saying, okay, what are we looking for? This is union. So this is or. So we're looking, is this statement true, or is this statement true? Okay? So, I think I can fit this on this page. So we're going to say the negation of P and Q union with P union Q. This is the problem that we began with. And obviously that is a much better marker. Okay, so here we're at right now. So we have the negation of P and Q, we have P or Q, and we're going to talk about the union between the negation of P and Q and P or Q. So this is an or statement. Either or of these statements can be true. So what do we end up with? False or true? True. True or true? True. True or true? True. True or false? True. And so all of it ended up being true.